Driving down a familiar road in the rain, believing conditions are normal, the asphalt ahead suddenly dissolves into a violent, muddy wall of rushing water. This is a flash flood. While hurricanes can be tracked for days, these events strike almost without notice, making them the fastest and deadliest natural disasters in the United States. The aftermath reveals the sheer power of the surge. These torrents possess enough energy to snap paved highways in half, exposing the raw earth beneath. The speed of this transformation reveals how quickly a familiar environment can turn against us. When a landscape is dismantled this rapidly, the stability we rely on for travel can vanish in an instant. These disasters are often triggered by localized thunderstorms. When a slow-moving storm stalls, it can release several inches of rain in less than an hour. To identify these threats, meteorologists monitor rainfall using advanced radar networks and computer models that track moisture accumulation in real time. This data determines the level of alert. A flash flood watch means conditions are favorable for flooding, while a flash flood warning indicates that a flood is actively occurring or imminent. Despite these warnings, human delay is often the deciding factor. Flash floods do not wait for our response. They develop in minutes, making immediate action the only way to ensure safety. The transition to a flood begins with the soil. The ground has a specific absorption capacity, but it cannot soak up water indefinitely. When rainfall intensity exceeds the ground's ability to absorb it, the soil becomes fully saturated. At this point, every new drop of rain is forced to remain on the surface. Once saturation is reached, water can no longer move vertically into the earth. It pools, surging horizontally. Gravity takes absolute control. The water accelerates downhill, funneling into channels where its speed and volume rapidly grow. The resulting torrent is a gravity-driven avalanche of liquid mass. Arid desert landscapes can weaponize storms that are miles away. A dry channel can suddenly fill with a wall of water, trapping hikers even when the sky directly above them is clear. In mountainous terrain, narrow canyons accelerate the flow of water. This creates a battering ram of liquid, capable of obliterating local infrastructure. Narrow Appalachian valleys face a unique danger during nighttime storms. Residents can wake up to find their homes surrounded by water in total darkness, with almost no time to evacuate. Urban grids offer no relief. Non-absorbent surfaces like concrete turn city streets into deep rivers, overwhelming drainage systems designed for lighter rainfall. Suburban flooding can turn entire neighborhoods into inaccessible islands. When the streets are underwater, emergency crews find it nearly impossible to reach those trapped inside. Whether in a desert canyon or a city street, the landscape becomes a hazard when the volume of water exceeds its capacity to drain. Many people underestimate the danger of shallow water on a roadway. They see a few inches over the asphalt and assume their vehicle can maintain traction. The physics tell a different story. A single cubic foot of water weighs over 60 pounds. When thousands of these cubes move at high speed, the force is immense. Just 2 feet of rushing water can carry away large SUVs. Most flood-related deaths occur because people fatally underestimate this kinetic force. Victims are overwhelmed by the physical weight of the moving mass. Climate data shows a clear link between a warming atmosphere and intense rainfall. Warmer air can hold more moisture, leading to a higher frequency of concentrated, high-volume downpours. Our modern infrastructure was designed for a different era. Many drainage networks and bridges are now facing rainfall totals that vastly exceed the assumptions they were built on. When this infrastructure fails, the results are catastrophic. Overturned vehicles and destroyed roads are common sights in the wake of a flood that the system simply wasn't built to handle. As storms become more intense, we can no longer rely solely on aging concrete and asphalt to out-engineer the weather. The majority of flood casualties are preventable. They occur when individuals make the conscious choice to drive through water-covered roads, misjudging the depth and the current. Because the depth is impossible to judge from a driver's seat, emergency agencies emphasize one vital imperative: turn around, don't drown. Survival depends on preparation. Families should understand their flood risk, identify higher ground, and maintain waterproof emergency kits before the rain begins to fall. When an alert sounds late at night, there is no time for debate. A flash flood is an immediate threat, and immediate action, moving to higher ground and avoiding travel, is the only defense. Nature follows the laws of physics, and water will always follow gravity. Survival ultimately comes down to a single decision: the choice to listen to the warnings and act before the water arrives.